Hello everyone. So we have discussed about the basics of statistical quality control so far, the importance of the statistical control, the history and some of the philosophies, and how statistics is important and why statistic is important in the field of quality control. And with that, I introduce you the concept of statistical quality control charts. So in that case, I told you there are two types of statistical quality control charts. So today I'm going to discuss furthermore about statistical quality control charts, right, which was introduced by Swartz. And as I mentioned in my previous lectures, when it comes to control charts, there are two types of control charts. You have variable control charts and you have attribute control charts. So when it comes to a variable control chart, so in that case, when it comes to the variable, or when it comes to your target or nominal value, in that case it should be a continuous scale variable. For an example, it can be time, or it can be waist size, or it can be weight, distance, temperature, right? So anything, but the important thing is this variable should be in the continuous scale. So that is, the variable can be measured in fractions or decimals. So if you can find a variable which is in continuous scale, you can use that variable in order to construct a variable control chart. So in other case, when it comes to attributes control charts, so attribute control charts cannot have fractions or decimals, right? Your variable cannot have fractions or decimals. In this case, the attribute data arise when you are determining only the presence or absence of something. That is, actually we are concerned about the nominal categories. How many things are present here likewise. So for an example, you are checking the number of successes and failures, or the acceptance or rejection, right, correct or not correct, like that. When it comes to nominal scale, or when you are determining only the presence or absence of something, you can use the attribute control chart. So actually, when you have data which are following discrete distributions, we are applying attribute control charts to construct statistical control charts, right? So when it comes to variable control charts, there are many. So if I mention you few, you have X bar charts and you have R charts. So when it comes to X bar and R charts, we also call them as average charts and range charts. That is, for X bar chart, you can call it as the average chart, and for R chart you can call it as the range chart. And then again, in some cases we are using the X bar chart with the S chart. Now, why I have mentioned these two charts together is, when we are doing the analysis, if you are using the R chart, you have to use it together with the X bar chart, right? In some analysis, if you are using the S chart, again you can use it along with the X bar chart. So you have to use both charts in your analysis. That's why I have used it as a one point. Right, and then you have the moving average and moving range charts, which are known as MAMR charts, and then we have the target charts, right? So these target charts, also called as difference charts, deviation charts, and nominal charts, And then you have QSUM charts, that is the cumulative sum chart. If you can remember, when you are doing some of the analysis, or if you have fixed regression analysis, and if you want to check the precision of the coefficients, in some cases we are using this cumulative sum charts, right? If you haven't used, you will come across with them when you are doing your final year research. Anyway, these are the examples for the variable control charts. So we'll be discussing few from these charts. We'll see how to construct them and what are their attributes and all. So when it comes to attributes control charts, again you have P chart, you have NP chart, C chart, U chart, you have so many. So when you say the P chart, you are considering about the proportion. It can be the proportion of the defectives, right? Or it can be the proportion of the accepted items. Likewise, if you're concerning about the proportion in order to construct your chart, we call it as a P chart, and it's coming under the attributes control charts, right? So when it comes to attribute control charts, we'll be discussing about few of them in our next coming up sessions. So first, today we are going to discuss about the R chart, which is coming under variable control charts, right? So what we do is, when we use the R chart in order to monitor our process, the R chart is always looking for out of control points, right? So if you use your R chart, and if you can identify that your process is out of control, then what you have to do is you have to stop your process and you have to find out the special causes. That is why this happened. What are the causes for this out of control signal, right? And then you have to eliminate them from your process. So once the effect of the out of control points from the range chart is removed, then what we do is we again use the same process and draw the X bar chart, or you monitor the same process using the X bar chart to get confirmed whether our process is in control, right? So that is, first you take your data set, you draw R chart, you have to check whether your process is in control or out of control. If your process is in control, no problem, then you take the same data set and then you draw the X bar chart, and again we can check whether your process is in control or out of control, right? But when you find if your process is out of control when you are using R chart, then you have to stop your process, and then you have to check the special causes, which are the reasons for this out of control signals, and eliminate them, and then only we are going to use the X bar chart, right? So you can see, when it comes to the R chart, when you draw your central limit or center line, the central limit is equal to R bar. That is, you have to consider the range value of your process and take the mean or the average range value, and that value can be considered as the central limit. And then you have the upper control limit. That is, the upper control limit is you take the average range value, multiply that with D4. Then when it comes to lower control limit, that is LCL, that is you take the average of the range values and multiply that by D3. Now the problem is, what is this D4 and what is this D3? right? So when you are constructing these control charts, there is a special table which is known as the factors per variable control charts. You can read all these factors from this table. Now I'm going to show you that table. Right, so I have uploaded this table to Cal, so you can find the table and you can download the table through Cal. So you can see this is the table. So if you look at this table, you can see all these. See, in this case you have A values, A2, A3 values, B3, B4, B5, B6 values, simple D2 values, simple D3, and capital D1, D2, D3, D4 values, right? So here this table is known as the factors uh, for constructing the variable control charts in the field of statistical quality control. So by reading the factor values, that is in our case, since we are interested in constructing the R chart, we want D4 and D3 value. So we can read D4 and D3 value from the table and construct our R chart, right? So I'm going to show you one example. If you look at this, it says in the manufacturing of a certain machine part, the percentage of aluminium in the finished part is especially critical. For each production day, the aluminium percentage of 5 parts is measured. The table below consists of the average aluminium percentage of 10 consecutive production days along with the minimum and maximum sample values, that is the minimum and maximum aluminium percentage for each day. The sum of the 10 sample means is equal to 258.8. So the question is, you have to construct the R chart and identify whether your process is in control or out of control. So how you are going to do this, right? So first you have to understand your problem. Now in this case, what is the problem? Your process is you are manufacturing a machine part. In that machine part there is a aluminium, we are using aluminium in the construction, and the percentage of aluminium in the finished part is very critical. That is, it's something very important. So you have to, what you have to check is, if your product is a good one, you need to have the correct percentage of aluminium in the finished part. So in order to check, or in order to monitor the quality of your product, what we have done here is we have measured the percentage of the aluminium in each and every part. So they have selected 10 consecutive days, and in each day they are checking 5 parts. That is, when you take day 1, your sample size is 5. You take 5 parts from your production and write out their aluminium percentage, and then calculate the mean value that is there, and calculate the maximum value and calculate the minimum value. Likewise, you do it for 10 consecutive days. Now the very important thing is, here you have done the same thing for 10 days by taking 5 parts in each day. So that is, if you consider one day, a sample size is equal to 5, right? In a day, a sample of 5 observations, a sample of 5 elements have been considered in order to find out the sample mean, the maximum value and the minimum value. So that is, when you consider this particular problem, the sample size should be equal to 5, right? It's very important because most of y'all will confuse this, because since you have 10 points, sometimes you may think the sample size is equal to 10. It's not 10. These 10 points are 10 consecutive days. But if you consider one day, you are considering 5 parts, that is your sample size is 5. So in each day you have to consider the same sample size when you're constructing these charts. So that is also important. So what you have to remember is how to identify the correct sample size. Because if you do not identify the correct sample size when you are reading the factors from the table, you will get, or you will end up with wrong values, right? So for this particular problem, the sample size is equal to 5. So that you have to keep in mind. So I'll show you how to do the calculation. So I have entered all these values into an Excel sheet. So since we are interested in constructing the range chart, first you have to calculate the range value. So we know range is in Sinhala Parasaya. So range is the difference between the maximum and the minimum value. So for each day, they have given you the maximum and the minimum value. So I'm going to calculate the range for the 10 days range values. So if you take day 1, I have to take the maximum value and subtract the minimum value. So I have to do the same thing for all 10 days. So I'm going to drag this one, right? See? So I have the sample range values. And when it comes to control limits, the central limit is equal to R bar. So R bar means, if I calculate R bar here, so R bar means the average of the range value. So you have to take the average of these you have to take the average value of these values, right? So in that case, I'm going to find out the average value. So you can use Excel, you can use the average inbuilt formula. So I'm going to select these values since I'm interested in the average of these range values. So the average is equal to 3.7. So the average is the central limit. So the central limit is equal to 3.7. And when it comes to upper control limit and the lower control limit, if I show you again the formulas, upper control limit is R bar, that is the average of the range values which we have already calculated, 3.7 into D4. And the LCL, the lower control limit is R bar into D3. So R bar is 3.7. Now we need to find D4 and D3. So that you have to read from the table. So this is where the sample size is important. See, if you look at the first column, you can see that shows the observations in sample size. So in this question, we have 10 consecutive days, but in each day you have a sample of 5 observations, so 5 elements. So sample size is 5. So you have to read this value, this row. You can see when sample size is 5, D3 value is equal to 0, D4 value is 2.115. Right? So I have put these values here. D3 is 0, D4 is 2.115. So now we can construct the UCL and LCL, upper control limit and lower control limit. So the upper control limit is D4 times R bar, that is 3.7, and the lower control limit is D3 times R bar, that is 3.7. So you have the central limit is 3.7, upper control limit is 7.8, and the lower control limit is 0. Right? So what you have to do is, now you have to construct your R chart. So first you can take these range values, and I'm going to draw a chart using these range values, right? So that is in the first day the range value is 3.1, second day 3.2. Likewise, I have plotted the range values in a chart. So that is my x-axis is the days and my y-axis is the range, right? Now in the same chart you have to draw the control, this control limit, that is the central limit, upper control and the lower control limit. So you have to draw a lower control limit here, that is with the value 0, upper control limit with the value 7.8, and the central limit with the value 3.7. So I have done that. I'll show you. See, so I have constructed the R chart now. You can see the control limits and the observations, and you can see all the observations are within the upper control and the lower control limit. That is, we can conclude our process is in control. Okay, but there are small problems, but in this case I'm not going to discuss about those problems. I will just explain you the basics when you how to construct your R chart and how to identify whether your process is in control or out of control, right? So in this case, since all the points are within the lower control and upper control limit, we can consider our process is in control. So this is how you construct R chart with the use of your data set, and also with the use of the factor table of the variable control charts, right? So I hope that is clear with you how to construct the R chart. Now I told you when you use the R chart, you have to use the X bar chart as well together with the R chart. Now for this particular problem, we can see it's when we use the R chart, our process is in control because all the points are within the LCN and the UCN. So that is in order to confirm this, that is in order to confirm that our process has no other problem, we can draw or we can construct the X bar chart using the same data set, right? So in that case, when you construct the X bar chart, right, so X bar chart is something which monitors the location of the process over time based on the average values of the observations. So when you construct the X bar chart, we want to have the mean value, that is the population mean, and the population standard deviation, that is mu and sigma. So you take the central limit as mu, and you take the upper control limit as mu plus A times sigma, lower control limit mu minus A times sigma, right? So A value can be read using that factor table. So I'll show you. See, if you look at the second column, you can find the A value. So using the same process, you can construct the X bar chart. But here, if you construct the X bar chart in this using these formulas, you should know the population mean and the population standard deviation in order to substitute for mu and sigma, right? So in this case, since we have no idea about the population mean and the population standard deviation according to this particular question, but we know the range value. So in that case, if you want to construct the X bar chart, there is another formula, that is for the central line you can take X double bar. That is, X double bar means when you look at your data set here, when you look at your data set, we have the sample mean values, mean of the first day, second day, likewise. So if you take the mean of all these 10 means, that will give you X double bar value, right? So that can be substituted here. And A2, when it comes to LCL and UCL, you can see the formulas are x double bar minus A2 times R bar, x double bar plus A3 times R bar. So x double bar and R bar we know how to calculate. Again, A2 and A3 that can be read using this factor table. So you can see in the third and fourth columns you have A2 and A3 values. Now according to this question, since our sample size is 5, you can see A2 value is 0.577, A3 is 1.427. So you can substitute the values to your formula and construct the X bar chart as we constructed the R chart. But I will do examples in the coming sessions, right? So what I want you to understand is the concept of constructing these charts using the data set and the table. And then again, I told you sometimes we are using the S chart with X bar chart. So S chart is when you know your sample standard deviations, you can construct the S chart. So if you are constructing the S chart, these are the formulas for control limits, right? So that is basically you have replaced the R bar here in the when you construct X bar chart with R, that is range, you are using R bar here. So we have replaced R bar by S bar when you use the S chart. So the next problem is how you are going to calculate this S chart. Alright, so in S chart, first you have to find out the standard deviation of each observation using the normal standard deviation formula, that is summation xi minus x bar squared over n minus 1, the whole thing square root. And then what you have to do is when it comes to S chart, the upper control limit is equal to S bar into B4, lower control limit S bar into B3, and the central limit is S bar. Now why we use S chart without using R chart is, we are using this S chart in order to control the variability of the variable, right? So that is, if the sample size is greater than 10, S chart is more effective than using the R chart, right? Because we know even when it comes to basic statistics, when you have a big data set, right, rather than talking about the range, it's when we talk about the standard deviation, it's more accurate, right? So likewise here, if the sample size is greater than 10, we always prefer the S chart rather than using the R chart, right? So when the sample size exceeds 10, what we do is we use the X bar chart together with the S chart. And if the sample size is less than 10, we use the S bar chart together with the R chart, right? So as I told you, when you use the S chart and the R chart, first you have to construct the S chart and R chart, and then you have to check whether your process is in control or out of control. And if your process is in control, you have no problem. But if it is out of control, you have to stop your process and find out the reasons why why you are getting out of control signal, and then you have to eliminate those causes. And then if your process is in control, then you can construct the X bar chart and find out whether your process is in control or out of control. That is to confirm what your decision, right? Using X bar chart, right? So that is how we use X bar chart R chart and S chart, that is all the variable control charts, in order to monitor whether your process is in control or out of control, right? So I hope you have understood how to construct your variable control charts using a given data set and using the factor table, right? So if you have any question, you can always talk to me. You can send me an email, and or else you can raise the question in our next online session, right? So I will stop for today, and in the next session we'll come up with the attribute control charts and move on variable control charts. Thank you.